Hi there, I'm Sushen, and the topic that I'm going to talk about today for the podcast is the basic mechanical principles of running and walking. Right, so basically, running and walking are part of the human motion. Right, now human motion consists of actions and patterns which includes, like I said before, walking, running, lifting, jumping, and throwing, among many others. But today, I'm just going to focus on walking and running. Right. Now, you may be wondering, how on earth is running and walking related to engineering? Now, you may be surprised to find out that actually, walking and running are actually governed by Newton's three laws of linear motion. Now, running and walking are basically human motions or general motions characterized by the translation of the body's center of gravity due to rotary motion occurring in the lower body and the upper body. Right? There are many factors and forces that actually controls running and walking gait. These factors and forces includes weight, the normal reaction due to friction, air resistance, and your internal muscular force. Humans accomplished by a strategy known as double pendulum. Now, during forward motion, the leg that swings forward from the hip is known as the first pendulum. When the heel strikes the ground and rolls towards the toe, this is known as an inverted pendulum. So this is basically what is known as a double pendulum, right? Now, the process of walking recovers approximately 60% of energy used due to pendulum dynamics and ground forces. As mentioned before, we can relate walking and running to Newton's three laws. Looking at the first law, states that the body will remain at rest unless acted upon by force. Now, the legs produce a ground reaction force, which then results in horizontal propulsion and therefore movement. Right? The momentum generated by the legs is then transferred to the upper body. It can also be noted that a change in inertia is greatest at takeoff, at least when there is no acceleration. From Newton's second law, that force equals to mass times acceleration, we can see that the greater the leg drive, the greater the motion that is imparted to the upper body, which means faster walking or running. Now, according to Newton's third law, the force for walking and running is provided through the upward and forward ground reaction force, which is derived from the downward and backward drive of the foot. Right? We can say that the smaller the vertical component, the greater the horizontal component. This means that if you have too large a vertical component, you result in a bouncing motion. In running, the foot should strike as close as possible to the line of gravity. If the foot strikes too far in front, you tend to have backward thrust, and this is inefficient movement because you need to spend more energy in order to achieve the same velocity. This is the end of my podcast, and I hope you found this interesting and I hope you liked it. Thank you.